Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muhammad Azhar bin Wan Harun, and today I would like to simulate for question 2. There is the base for every graph that we will be construct later. Okay, uh, when we run, and this is our base graph for constructing signal, time domain, and frequency domain, which will be construct using the parameter that we had calculated. Okay, next. Okay, uh, here the equation 1, I have highlight. Okay, I have highlight here is the base of parameter that we have to calculate from manual calculation. So below here is our signal for in time domain for harmonic 5, and then for harmonic 10, and lastly for harmonic 20. Here is harmonic 20. Okay, I will run. Okay, this is the simulation for our harmonic 5, 10, and 20 graph. So here on the top one is for harmonic 5, in the middle is for harmonic 10, and lastly at the below is harmonic 20. Okay, that's all.
Assalamualaikum warahmatullahi wabarakatuh. Okay, so my name is Muhammad Safi Masali. So I will be presenting for the frequency domain signal for tablet 5, 10, and 20. Okay, so here is our coding for the frequency domain for the harmonics. So for all the harmonic signal for 5, 10, and 20 is almost the same. Only the difference here is our looping start over here, which for harmonic 5 here, we start with 5. And here F1 is representing our frequency that has given that we have selected in the earlier stage of our project. So this is and then here is where we end the plot for our signal, and here is little setting for our signal. So I will run one by one. For first is for frequency domain for Phoenix 5. So here we have the signal for frequency domain for Phoenix. So next for frequency domain for Phoenix 10. So here is our harmonics for frequency domain for, and the last one for our harmonic signal for our frequency domain for harmonic 20. So here is our simulation for harmonics 20, the frequency domain. Okay, that is all from me. Thank you.
Test mic 1 2 3. Okay, Bismillahirrahmanirrahim. Assalamualaikum and a very good morning to all of you. My name is Muhammad Nazmi Biramli, DE1900204, and I will continue for the low pass filter part. As we know that if you take a look at the this simple low pass filter first order circuit, we make a little derivations, as we know that we have to times 4 with the frequency to find out the value for the cut-off frequency, so that we get the cut-off frequency value is 224 kilohertz. And then let's we move to the coding. in the MATLAB. So as we know, we said the Fs is 1 million and Fc is equal to 224,000, which is Fc is sampling frequency and the Fc is a cutoff frequency, and then we make a formula which is Fc over Fs over 2, and we plot the two graph here, which is the first graph is the filter frequency response, and the other graph is the same graph but without the logarithmic scale. So as we take a look at the result after we run this coding, we have both of this graph, which is a graph for frequency in hertz versus gain in decibel. As we take a look at the result, the first graph that we get, the curve of the graph is a little bit delayed than the second graph, which is the curve from both graph are actually bent at the different frequencies. So this is the result for the low pass filter question.
Okay, I'm Karthikeyan Alaike Murugu. I'm here to present low pass filter in time domain. So this is our sampling frequency and cutoff frequency, and these are our codings for time domain. Okay, right? This is our input signal for time domain. Zoom in. Okay, this is our input signal. Okay, let's go for time frequency. Sorry, frequency domain. Okay, this is our frequency domain coding. Both of that are the same need, the coding all. Okay, now run. This is our signal for frequency domain. The difference between time domain and frequency domain. Time domain shows how a signal changes over time, while frequency domain graph shows how much of the signal lies within each given frequency at over a range of frequencies. Thank you.